right, Melanie put up number 1. So how did she solve this right here? How did she factor that? What'd she use? GCF, right? And the greatest common factor between 5 and 10 is 5. So very good job. All right, Kayla's going to put up number 2 for us, right? Perfect. All right, Isaac, what's the biggest number that those numbers is? Okay, what's the leading one negative? Negative 6. You go with the letter and call it. Yep. No, there you go. Very good practice. All right, now what's negative 12 divided by negative 6? Yep, perfect. Yep, all right, hold it down. All right, run those first first.
That's not right.
So then do 768 and then divide it by. I'll start with a real big one.
Precious.
Kaylee put up number 3 for you. Y'all okay with that one? Why didn't she take out a y on number 3? Like, it had y cubed. Why didn't you take out a y when she took out the x?
Because there wasn't a y.
There you go. There wasn't one in the back one with the 5 and the 10. Yeah. The leading one was negative, so that's why I'm going to take that. Remember the same form that we did before? The one with x anything, the one in the very front, the x squared. That one you don't forget. The one with there's a square. Anything in the front, whatever's in the front.
In front of parentheses.
Whatever's in the very front. See how the 12 is in the very front?
Yeah.
And then we put that out to the very, very front. We have a negative 6. So a positive 6. Like 441 matches like that.
Okay, I found like 27.
How's this black man?
Yeah.
All right, so let's look at number 6. Number 6. So there's a y with the first term, and there's a y with the second term. Why didn't she take out a y at the very front? There you go. It's greatest common. It's got to be common between all of them, right? All right, so let's look at Michaela. Did number 7. 768. What's the biggest perfect square that divides into it? 256. Now do y'all see why this is so important and we were stressing those perfect squares? We took the test and we took the quiz. You gotta know them. All right, so 16 square root of 3. And then Hope is working on number 8. What y'all get for number 8?
Wait, I have a question.
What?
Okay, so are only like 1 through 25 considered perfect square?
No, that's just not ones we're worried about right now. You've got 26 as a perfect, could be a perfect square, 26 times 26.
Is
27
27?
is 27.
What's the largest number though?
The lowest one,
Largest.
infinite. Whatever number you want times itself is a perfect square. So like 1,000 times 1,000, that'd be a perfect square. Or 1,000,000 times 1,000,000. All right, did y'all get 8 square root of 6? We need to go over this one? Yeah, we need to go over that one? All right, so she did the tree diagram, which that's okay. That's fine. So 576. What was the biggest perfect square that divides into 576? How much? 24 is not a perfect square. 25 is a perfect square. Do you have those? Let's go over our perfect squares. What's the first one? What's the next one? 2 times 2. 4. What's the next one? Yep, keep going. Yep. Yeah. Keep going. 49. 64. Come on, everybody, let's go. 81. Yeah, that's good enough. All right, so 576. So which one?
24 though, like 24 squared.
Oh, you're saying 24 squared.
Yeah.
Oh, that's what you're saying. Okay, so what is 24 squared? 24 times 24? How much is that? 576. So that is already a perfect square. So that answer should just be how much? 24. Very good. Very good. So you got to listen to the question. The question I asked you was what was the biggest perfect square that goes into it. And 24 is not the perfect square. What was the perfect square? 576. All right, let's talk about yesterday. Yesterday we learned 3 things. So we're going to go over that today. So what was something that you learned yesterday, Jess? Yeah, talk about parent graphs. You got to know those. What else did we learn? What did you learn yesterday? Noah, what you got?
Absolute value.
Absolute value is a parent graph. We learned how to graph those on our calculator, right? So you need a graphing calculator again today. If you don't have one, there's a couple right over there for you. All right, and then what else did we learn yesterday? Last one. Oh yeah, we learned how to describe, right? Okay, so here's what we're gonna do. We are on 31. So we're on page 31. All right, do you see your partner? See them? Looking at them? Finding them? All right, we are going to work together with our partners today. We need our graphing calculators. And go. We're on page 31. Let's start off. 31. Page 31. Yes, ma'am.
Follow your payment checkout, please.
Yes, ma'am.
Thank you.
You want the document? What happened?
You see him get his arm?
Because he got hit like 18 times. He doesn't want to
Ms. Blackman?
Yes, ma'am?
Hey, can you send Isaac McAdams to, Mr. Ferris's office?
Yes, ma'am?
Thank you.
Should be. I was in the office just last week.
If it's on the outside, it says like it's minus.
You want them up?
No?
These are the absolute values. Numbers just y equals.
How about the first one on the page? Okay, down
Left. Okay, yeah.
Now you found it. Wait, so now grab the paragraph away. Oh, we already did. You can grab the paragraph. Okay, go there. Hit the down button. And do the paragraph.
We always.
Oh, that's what the fine.
Yes. You want this one that we can actually see how it goes. But try to graph it first. Then graph it. Alright, let's talk about this. It's got a negative in the front. Okay. That negative in the front. So it's gonna go from B like this to upside down B like that. Okay? And then it says that one is on the inside. That one is on the inside. That's why you start that's subtraction to that. It's outside. It's outside. Same side. Let me change it. Up, down. -2. I got it from there. Your graph go out one, like up one, down one. But this is negative, so you go out one, down one. Both sides, I think I'm -3. a little smaller. You're not going to go out one and up one. You go out one and up one. Out one, up one. You go out one and up. Have a what?
I mean, I know this one. I know why that one went down instead of up. Like
this one, it doesn't look like that.
And you say different. You say different. Get here, did that extra time. How we Okay, I think number 6, but what about this value? Okay, so the 3 is doing what to that graph? Adding, subtracting, multiplying, or dividing? Okay, so it's being multiplied. Then instead of going out 1 and up 1, it's going to go out 1 and up how many? Mm-hmm.
So it's still going to start at the origin.
Yep, it's still going to start at the origin.
But it's going to making the lines.
Yep. Did you graph it on your calculator to see what happens? Yeah. And it should be stretched. Alright, how are we doing on 5? Are y'all okay? Yes? Alright, what about 6? Are we struggling a little bit on 6 because of that 3?
Yes.
Okay, so right here on 5, this negative told me I was going to flip it upside down. That one told me I was going to move left 3. That one told me I was going to move down 2, right?
Right.
But when you multiply something, that's not a translation and that's not a reflection. What was the other vocab word? Dilation. So instead of going out 1 and down 1, or out 1 and up 1, if it's being multiplied by 3, how much would you go up?
Up 3.
Because 1 times 3 is 3, right? So you would still start where? Where is this going to start? At the origin. And you're going to go out 1 and up 3. Alright, did you graph it on your calculator and did you see how steep, how much it got pulled upwards, it got pulled vertically? Alright, so did y'all get the same graph? Yeah? Alright, what about number 7? Number 7, where's that one going to start? At the origin. But instead of going out 1, up 1, I'm going to go out 1 and up how much? A half. So I don't really want to graph that one. So I can go out 2 and up how much? What's 2 times a half? 1, right? Alright, what's the next one I could do? I don't want to do 3 because that's going to do a decimal. What's 4 times a half? 2. Did y'all graph it on your calculator?
Yes.
See how it got wider?
Oh, because okay.
Because the 1/2 means that I'm going to have to go out 2 before I go up 1, and then 2 more before I go out 1.
Right.
So you just multiply, like, if you're plugging them in, like 1, you just put that 1/2. Or if you put 1/2 and 2, that'd be 1/2 times 1. 1/2 times 2, which is 1. Y'all okay on that one? Okay, what's the next page we're going to? 32. What's that word omit 12 mean?
Don't do it.
Don't do it, right? Alright, so let's go to the next one. Alright, now look at the directions. Let's look at the directions. What's the only thing that it tells you to do for 1 through 5? That's it. That's all you got to do. It's tell me the kind of parent graph it was, right? Which we only did 3 of them this. Alright, see what you can do with that. Anybody having calculator issues that you need to help them with? Yes, ma'am. Yes, I can use that. Like, look, I know how to get to that.
Okay, well, first off, you don't use this.
I didn't do that.
Or if I didn't need
When doing absolute, once you try, go to.
to add to. Yeah.
I don't know.
I don't have my car.
I can do
I'm sorry, but she is. Her car's getting broke for like, I have some
And okay, so now you have your parents' function. So then, okay, for
I have no clue, but she can, her point is like 12.
say, let's go to the math.
Ms. Lightman?
Yes, ma'am.
Hey, can you send Isaac McAdams to Mr. Ferris's office?
He already went earlier the first time they called him. Did he not get there?
I don't know, he just called me back.
Oh, well, there's Isaac right there. Does he
Hey,
want
did
him?
he already go?
Yes, ma'am. Does he want him back?
I don't know.
Okay. Isaac, just
Oh,
go.
let me call him.
Okay, hold on. Let's let her call her. See what's going
Hold on just a second.
on. Okay. Did you do it without me looking?
Yes. Okay.
Sorry, you've already seen him, we're good.
Okay.
You got the bell, that's your parent.
It was a group start. It's pretty cool.
What happened?
It happened. Just know tomorrow I'll probably be called up.
Why?
Because it's probably we're making fun of some stuff. That she brings 12 apples out of class. He's like, so, right, y'all laugh, right? We laugh every day at him eating apples. And, you know, today we're like, hey, let's mix it up. So every time we took a bite, all of us would go at the same time. One of the times we were all like real loud, and the whole class, no one didn't hear it unless you had your earbuds.
Alright, Isaac, how are we doing here? We're on the next page.
12
Good? Where's the next page?
Oh, I don't care.
Well, you were showing me, okay, how we doing?
What are we doing? Are we?
On page 36. We are omitting number 12.
This is absolute, right?
Yep, let's see. Linear, or what's the other one that you call it?
Identity.
You just put identity. I just want you to know both words.
What's the other page 33, please?
Alright. Yeah, go ahead if you want to. Alright, 32. Let's talk about 32 real quick. Number 1. What'd you get for number 1? Constant, because it doesn't have a what? It doesn't have a slope. What about number 2? Absolute value. Value. Alright, what about number 3? Identity, or what else do we call it besides identity? Linear, right? And then what about number 4? Same thing? Identity / linear. Alright, and then what about last one, number 5? Absolute value. Okay, let's look at directions, because our biggest thing here lately on our tests and on our quizzes has been that we just haven't read directions. What does it tell you to do first? Name the parent function for all of them. Then what's it tell you to do? Describe, right? All right, so go ahead and try those real quick. Let's see what we can do with them.
Me and my kids were about to take a picture. And you know how like
I think I'm going to do it.
one.
So describe, name the parent graph. And describe what happens. Make sure you just name the parent graph first. Let's see if that happens to you already. I haven't named the parent graph.
So, are you going to probably? Is this really like you counting?
We made him do it. He would bring and he goes.
Because if not, you're telling us to do 1 over X.
What do you say?
Paragraph. Let's see what happens. Yeah, and then down 6. What happened with the slope? What this guy do? Did he stretch it vertically? Did he stretch it horizontally? Did he press it vertically? Did he press it horizontally?
What the heck?
This man.
That way.
I don't know.
This one?
It's probably
Yeah, this one.
covered.
That's right.
12 hours to get you killed.
All right, what about number 6? Now look, listen, I'm not gonna write all these. So listen up real quick. What's the parent graph of number 6? The identity or the linear? What happened to it? Up 4. Y'all okay? Anybody lost? All right, what about number 7? Absolute value. What happened to it? Beautiful. All right, what about number 8? Absolute value. Now there's 2 things here. Beautiful. Inside, you take the opposite sign, so it moves right 2 and then up 3. Are y'all okay? Please make corrections if you got one wrong, okay? Please make corrections. All right, what about number 9? Identity or linear, right? What did the 1/3 do? Stretched it horizontally. Beautiful. And then the 6? Down 6. Awesome. All right, what about the 10? There's 3 things on number 10. Absolute value. Hold on. That's absolute value. This guy right here in the front reflected over the x-axis. What's this one? Left 1 and down 7. Awesome. Are y'all okay? Yeah? All right, and then number 11, what kind of parent function? Identity. What did the 2 do? That's easy. It moved it up 2. What did the 5 do? Dilated, which means it did what? Stretched it vertically, right? It's pulling it up. Or you could say compressed horizontally. They mean the same thing, okay? Are y'all good? All right, and next one we're going to do page 33, and we're going to omit number 14. What's omit mean? Don't do it. All right? All right, so the same directions for 13. What was the first thing for 13? Name the parent graph, absolute value, and then describe to me what happens. So there's 4 things on this one. What's the negative in the very, very front tell you? Reflects it over the x-axis, right? What's the 3 do to the parent graph? Dilates by 3. What's that mean? Stretched it where? Vertically. Very good. Or you could say compressed horizontally. They mean the same thing. All right, what about this one? Oh, inside. Right 1. Remember, inside it's left and right. And then up 2. Very good. So reflected over the x-axis. Dilated 3, which stretched it vertically. Stretched it vertically. And then right 1, and then up 2. Are y'all okay? All right, and then the other ones, what are you going to do for the other 2?
Graph.
Just graph it, okay? All right, so you can do what you can do with those 2. This hand. Just like 3, because the negative looks upside down. They all have it as unique purpose. Alright, there we go. Alright, I can try that again. You need to grab the mouse tracker. When you get to 3 guys, now then after this.
What is the
Really, if you hadn't missed 2 days, you wouldn't have had a smear. Alright, here you go. Look at these.
Hold that again. We're going to have to ready.
Where's the 2 at?
Yes.
Hold that. Hold this. Okay. Big 2. This one, you were to grab this one, you would go up 1. How much would you go up?
If it does start I don't know why because I'm
Right 1 and then down. So your left 1 and now come
I had to eat something.
No, we're in front here though. So you go out 1 and up 1. Okay, well,
I
3
tried
inside
so
1.
hard. I left like 2 days so
Okay,
hard.
which way to take it? You did the opposite side. Which way to take it? Okay, so the opposite arm, which is opposite on the shoulder. Where does it take to the left or to the right? Okay. Go up. You just told me to go to the right. That's why you use pencils. How are we doing? Yeah. Then it's 1 and 1, because then we're out front 1, right? Why are you going way up here? So when you go third, or you go right 3? Just let me go away. No, you're right 3 and up 3.
Low.
Alright, this is why
I got you, ice cream.
Alright, Noah, what did this guy tell you right here on 15?
Go up to.
There you go. Alright, and then Isaac, from this point, because it told me to go up 2, how do I get my other points? There you go. You gotta go on both sides, right? Alright, Matthew, on number 16, since that 3 was on the inside, what did it tell you to do? Go right 3. So you start at the origin and you go right 3. Alright, Ethan, how do I get my other dots? From here. I got my, this told me to go right 3. But how do I get all the other dots to make the graph? There you go. And I got to do the other side. No. So I got to do the other side. So I go up and left. Y'all okay? Alright. What would be the domain on that graph? Yeah, just for giggles. Let's make sure we remember how to do that. All real numbers. What would be my range? 0. Bracket or parentheses? Bracket. It actually hit at 0. That actually has an x value of 0. Then where's it go up to? There you go. Alright, one last page. And then we're going to talk about checkpoints and all that good stuff. Yep.
We have them today?
No, but we've got several people that need to finish the one from yesterday. Alright, 3 more. Alright, Isaac. Okay, what's the plus 4 take to do on the side? Okay, left or right? Up and down. Okay, don't put that pencil there. Because then you got a minus 2 that's in the back. What's the minus 2 back to? Down to, then negative. So you had 2 numbers, you had to do 2 moves. On the other one, this one you only had 1 number. That's why you only had 1 number on the side. Okay? Alright, then from there, the number in the front corner, right? It's positive.
Oh. You think you should put her on quarterback now? That's all you're. That's great.
Alright, now you got 2 numbers on 18. What's the first number tell you? Okay? And then, there you go. Alright, now, put your dots. Now, what's this tell you? Put your dots. What's that tell you? So instead of going through here, you got I'm still trying to figure out how to do this. It's going to get you, it'll be fine for next week, but it's not going to be good for you next week. Alright, what's it say? You go up 4? Don't say everything.
I'm too scared to put on my
Yeah, looks nice. Yeah, more. I see those. There's nothing you're adding or subtracting. There's nothing you're adding or subtracting. We're going to start. There's nothing on the inside. There's nothing on the outside. We're going to start. But then the fourth not there. Nothing on the inside. All right. Okay, what about 17? What do you do?
on 17? Down 2, and that is left 4. Very good. All right, and so then we're going to go out 1 and up 1 on both sides. Y'all good? Yeah? No? Any feedback? Yes? All right, here we go. Next one. 18. That does 3 things. What? Don't say over. Reflects over the x-axis. Yep. What's that tell you? Inside. Inside you do opposite. Left 2, down 3. But now what's this guy tell me to do? There you go. So how am I going to graph that? You go down 1 instead of up 1. Yep. All right, last one. And then we got to do some checkpoints for a couple of us. All right. Do you have any number on the inside? Do you have any number on the outside? Oh, no, you don't. Where are those numbers on the outside? Look at 18. Look at 18. What number was on the outside of number 18? The 3. Do you have a number like that on 19?
Oh, man.
No. So where am I going to start? At the origin. Now, what are you doing to that 4? It's a dilation, right? You're multiplying. You're going to go over to the right 1 and up 4. And then you're going to go right 2 and up how much? 8. 5, 6, 7, 8. You see how steep that was? Are y'all okay? Yes? No? Maybe? Yes? Okay. All right. So here's what we're going to do. Listen up, listen up, listen up. We are 2 days behind because we were out for 2 days, right? So tomorrow, if you're looking at your calendar, we were supposed to have a test today, right? We're not having a test today. Don't freak out. So since we finished everything, what are we going to do tomorrow? Study guide. Tomorrow's Wednesday, right? So then Thursday we'll take our test because we're 2 days behind. Are y'all okay?
Yes.
Does that make sense? And then with chapter 3, we can kind of catch up a little bit in chapter 3. So test on Thursday. Math workshop test will be next week. Math workshop test will be next week. All right, put my desk back, and we got to do some checkpoints.